Yesterday we talked about like information security concepts, general stuff related to basic concepts about hacking in general, bug bounty concepts, programs types, and some tips to find vulnerabilities in a fast way. Today we're gonna talk more about the if you want to say it, the web structure related to bug bounty hunting that is useful for us, as well as we will discuss some networking stuff, basic stuff. We will not go much deep. We will talk about, for example, how client server works, how DNS works, the relational internet as well. And I think we will have time to start hands-on for reconnaissance, which will be focusing on just the routes and seats. Maybe we will have a chance to discuss it today. Okay. So as a bug bounty hunter focusing on web application hacking, it is important for us to know how the web application works. Maybe we're gonna use Paint. Still active on Windows 11. Okay, so usually we have our computer. Yes, session is recorded. So usually we have our computer as a normal user browsing a website. So simply we use a browser, something called a browser. So browser, it is like an interpreter and a translator for the content found on the server. So we have our computer, and inside the computer we have the web browser. It is the browser, and also and then so for example we need to send a request typing, for example, google.com. Okay, so for example, we want to send a request. We want google.com. We send it through web browser, and then the web browser, it goes to the server. This is the server. So in a server, it like resolves and matches the content related to google.com and send a response to the web browser, and we view it on our computer. So this is very simple stuff. But if you want to go a little bit deeper, so usually when the client, which is us, we send a request using the browser to the web server, there is something called certificates, SSL certificates. So usually there are two types of connections. There is something called HTTPS and HTTP. HTTPS, all know, which is secure connection based on SSL, certificate, and public key. So this just ensure that your connections and your information that you are sending on the network are encrypted. So there is no possible stealing using man-in-the-middle attacks and such kind of attacks, or spoofing or so on, because HTTPS connection will prevent man-in-the-middle attacks, spoofing attacks. Also, we will later on in this session, we will discuss what is DNS spoofing, and we will do a practical demo just to make things clear. So simply web browser responds with the public key and the true certificate. The browser checks the validity of the certificate, and then it matches the keys. So if we wanna check live, for example, let's say we want to browse any website, for example. So usually I give examples on this program on HackerOne. It's called Yoti. Why I give examples on this program? Simply because I'm rank 1, so I'm so familiar in the structure of this program. It is a British program for identity stuff, governmental identity stuff. So let's say we want to browse yoti.com. So here, as you see, we send a request to the web server. So clicking on this key, it's like lock. Connection is secure. Certificate is valid. So this gives us all the important information. Let me take a screenshot. It will be maybe bigger in size so we can see it properly. So some of the information here are important. We knew that it is issued by a company called R3. Plus, it is issued to yoti.com. It is valid from a time to a time. So these certifications and stuff are important later on in order to know, for example, if we found a subdomain or an IP address through reconnaissance, how we want to prove that this subdomain or this IP address is related to the company that we are targeting on HackerOne, for example. So this stuff are important. We will talk about them later on in details. So also additional thing you have to check here, which is also important. See, when we talked about public key, so it is symmetric public key based on RCA encryption. So this is not important for us. It is just for the server and the client to exchange. So this is the subject, which is very important. So what is subject? Let me do another screenshot. Okay, so subject, why it is important? Because it says that this certificate is valid for this domain. So CN, which stands, I think, for a company, and I forgot the N. So the company domain is yoti.com, which is valid. If we want to see, for example, like Snapchat.com, and let's see Snap. For example, there is a Snapchat and there is a Snap. So how we want to know if they are for the same company? The lock connection is secure, certificate is valid, issued to Snapchat.com. We go to details, subject. Here there are much more information, which is better. So these are important information in subject of every HTTPS certificate. CN, which is the website, company website, Snapchat.com. The important thing is the organization, the O. Organization stands for Snap Inc., which is, this is Snap Inc., is the organization name. So any domain under or any domain or subdomain under this organization name will be valid in scope of Snapchat. So if you want to compare snap.com with the snapchat.com, let's check that the certificate of Snap. Okay, you see as well, it is the same. So here the website is a snap.com and the organization is a snapinc.com. So how this is useful, for example, let's check Snapchat program. Because some programs don't assign the scopes in details. So they say, for example, any subdomain related to Snapchat is in scope, for example. So here they assign this sccore.net star, which means all subdomains included, all internal Snapchat services are in scope. While you notice snapchat.com, it is not star, which means that there might be some third-party services which are subdomains under snapchat.com, but they are not related to Snapchat. They are not operated nor registered by Snapchat. So this is, and there are some out of scope, but they didn't mention all the out of scope. So this is important in case you find something, and notice that there is no snap.com. So there is no snap.com, but because you proved that the snap.com is an organization related to Snap Inc., so if you reported a vulnerability related to snap.com, it will be in scope. So we can add additional thing here. We can add additional thing here to the notes, tips to find vulnerabilities faster. We have here tips to find more vulnerabilities. So enlarging our scope by looking by if you want, checking the domains related to the organization name instead of just in scope domains. So and this happened with me. So we are in we are not in information gathering currently. Right now we're just if you want, in the basics. So we're explaining the basic stuff, the HTTP issues. We're coming. So information gathering section will start, I think, from the next session or from the mid of this session. But yes, here also, see, we are doing information gathering. We're gathering information about websites, about companies. I'm just checking the question. No. For example, our friend asked good question. Is this mentioned explicitly in the scope? No, some programs like Snapchat, they didn't mention, for example, in out of scope, any other subdomain not included here is out of scope. They didn't mention this thing. Also, in scope, they didn't mention that any subdomain other than this related to snapchat.com are in scope. So here you have to think smart, in a smart way. Here you have to think, okay, so if they are not mentioning so strictly here, so I can find the new domains related to Snapchat, because these domains are under the organization, which is Snap Inc. This high possible it will be included inside the Snapchat organization. As a proof, let's check some subdomains reported in the activity. Okay, we can add also here. Always check reported targets, and if you want also vulnerability types in a program activity. So now you will see that some hackers reported the vulnerabilities to subdomains that are not mentioned in scope. Let's see the disclosed report. So for people who don't know what is activity in HackerOne is like the place where hackers disclose information about the vulnerability that they found. And Snapchat pays good amount. Good. So yeah, let's see this. Stealing SSO login tokens on this subdomain, snappublisher.snapchat.com. So let's see if this is snappublisher.snapchat.com is in scope. Because they didn't mention that star.snapchat.com is in scope. If you notice, just this one, sccore.net is in scope. All of it. Oh, it is in scope. It is mentioned in scope. So let's check another subdomain. One of this, for example, leaked JFrog Artifactory username and password exposed on GitHub. So this gave us information, which is we can check third-party services. JFrog, it is a third-party service, I think, for coding. DevOps user, okay. It is a development platform. Seems using microservices stuff. Okay, so a hacker found simply credentials hard-coded inside a source code on GitHub. This gives us good idea that GitHub is acceptable if we found something impactful inside Snapchat. Plus third-party services. So we can target an Atlassian, Jira, for example, platform, but for credentials related to Snapchat. I just want to find a subdomain. Okay, this is a new subdomain, studio-app.snapchat.com. So let's search for it. Check. They didn't mention that studio-app.snapchat.com in scope. But at the same time, they didn't mention that star.snapchat.com is in scope. This means that any subdomain related to snapchat.com, any domain related to Snapchat, the whole Snapchat, is in scope unless it is mentioned in out of scope. So all domains related to Snapchat are in scope except support.snapchat.com and the returns.spectacles.com. So we enlarged our scope very deep. Instead of searching for just these domains inside these domains, we now are able to search in, for example, times 100 domains related to this, because we now have more possibilities to find new subdomains, new IP addresses, and new endpoints, and look for a lot of vulnerabilities. Yes, our friend said that here we are increasing the attack surface by checking the organization name. Yeah, absolutely. If something like that wasn't accepted, will the triage team mark this as not applicable, which affect the pointing in HackerOne? Nope, because first of all, this is not managed by HackerOne. It is independent program. And I reported before. Let me show you the report that I reported. Just give me a second. Because here see that we were talking about how web browser works, and suddenly we came across a new thing related on HackerOne. Because everything that I am teaching here, I'm focusing on to benefit from it in bug bounty hunting. So everything I teach, I try to do real scenarios and real examples from bug bounty. I will show you this report that I reported maybe last month. So remember when I told you you have to play it smart rather than just focusing on critical stuff? So I found information related to Ubuntu internal directories via an open port was found on advocates.snapchat.com. So let's see, is advocates.snapchat.com in scope? Let's check. Search, no, advocates.snapchat.com isn't in scope. So what did the team tell me? So simply I found an 3000 open port running Node.js Express framework. I tried checking it, and I found internal system directory exposures related to JavaScript files. Some programs accept this stuff. Some programs tell you, no, you have to escalate it or prove how attackers can use this information in further exploitation. So because I wasn't able to exploit it furthermore, I reported. If I had a good luck, they will accept it. If I had bad luck, they will not. So they didn't accept it. But see their response. Can you demonstrate how this information could be leveraged against Snapchat users or infrastructure? So they didn't tell me that this IP address or this subdomain is out of scope. No, they told me prove how this information can affect our users or infrastructure. So this is a proof that you can report subdomains not mentioned here, not mentioned in the scope section. Some programs accept this kind of stuff. So it is always to check the program policy. Why I reported this? If we check the non-qualifying vulnerabilities and exclusions, this section is about the vulnerabilities that they are not intending to accept. So they don't want to report it or to find it. So if we look here, we have something related to stack trace information. So generic information disclosure like stack trace without additional impact. So they told me that my bug fall under this section. So why I reported? Because I didn't find normal stack trace information, the generic ones like internal server error. No, I found internal directories. So if someone discovered path traversal or SSRF, they can use these directories to navigate easily between the files. That's why I reported it, and they didn't accept it. I can't show you other reports because I want them to be challenged for you, so you can find the vulnerabilities that I found. Okay, when we solve the challenge, we will explain them. So this is what I mean. If they don't have this message in the out of scope, they will accept it for sure. So it is always to check the program policies.
I have a question.
Yeah, sure, ask.
When you reported this bug, what is the rating if it's somehow ambiguous and you don't know the impact? The rating of this bug,
You mean you
how do?
mean you mean the severity?
Yeah, yeah.
Yeah. The severity is low, and as you see, I set it for low because you have internal directory exposure, but you don't know how to use them. Even if you are able to use them in other techniques, you have to check if, for example, you are able to escalate this information disclosures through SSRF. So the impact here now is not disclosing private directories. The impact now is in the SSRF vulnerability. So for now, this information are low. And the low vulnerabilities, the programs has the right to accept them or don't accept them. So here I got just noticed this stuff. If you want to check for rate limiting, remember yesterday we talked about rate limiting. Issues that merely results in spam annoyance without additional impact, like sending emails without sufficient rate limiting. What did we understand from this? Means that you can report rate limiting related to brute force issues, some denial of service issues, but not exhausting issues relating to user or resources. So for example, if you are able to send unlimited emails, it is not a bug. But if you are able, for example, to send unlimited data to the server, which will cause denial of service, it is a vulnerability. So you have to always differentiate by reading the out of scope. Also, what is the difference between in scope and out of scope? Simply in scope, sorry, as said before, we have some of us here, they know bug bounty hunting. Some of us they don't know, but all of us we have a generic knowledge about hacking in general. So we're gonna explain everything. In scope simply means the accepted vulnerabilities and domains. So the in scope are everything that you can report, that they are accepted. The out of scope are all things that you can't report. So if you found a domain in the out of scope section, it means that they don't want you to search for vulnerabilities inside this domain, neither report anything related to this domain. So we're gonna focus always on in scope. Sometimes we focus on out of scope to get a valid vulnerability in scope. For example, we need to search for an email, for example. So even we use Google Docs. If we want to use Google Docs, we use this inside Google Docs, for example. Let's cite in text Gmail, for example. Where Gmail is mentioned. So we found a Gmail from an IT license. Titus Wormer. So this guy may be an employee in Snapchat, working in Snapchat. And maybe we found an internal admin panel. So we try to gather all emails. We will talk deeper about this reconnaissance stuff later on. For example, if we have internal admin panel, we want to access it, a login page for Snapchat, for example. We gather all emails related inside the Snapchat, and we try brute force their passwords. Maybe one of them will be valid. So this we use out of scope for reconnaissance purposes. A lot of hackers ignore out of scope, but sometimes you find vulnerabilities by searching inside the out of scope programs. So see, from the support section, we found emails. Same here and others. Just checking if I answered all questions. Okay, I'm not gonna explain SSL handshakes so deep. I'm explaining instead the DNS, how it works. I think it's better. So let's check what is DNS. So we talked that sending request from our browser to server, and then server responds, and so on. We will also see it practically. So this server is called a DNS server. It is DNS server. So what is DNS server? DNS stands for Domain Name System. Are the servers responsible for like writing the website name and its IP address? Because actually when you're requesting a website, you're requesting the IP address, but the DNS is the one who has all the records and translate the name of the website that you requested into an IP address. So to understand more, I know some of you know this information, but it is better to start from basics, because it is very important to have great knowledge and understanding about this basic stuff. And some of us here are already networking major, so they will understand more than me. I'm not so good at networking. So let's say we're gonna browse google.com. So here, just simply, I opened inspect element. No, we're not in the information. Sorry. Okay, so I just hit inspect elements, network. So here it is like Burp Suite. We intercept all the traffic of the website. So Control R, and let's try to send a request to google.com. So we send a request to google.com. And here, when clicking on headers, requested URL is google.com, request method is get, and you can check here the remote address is this IP address. What does this means? So me, the client, I send a request to the DNS server requesting google.com. So the DNS server checked in his tables, is there a google.com here? This is its IP address, and they returned it back. Let me just explain something here. So just in a fast way. This is the client, which is us, and this is the DNS server. This is other DNS server, which is called the root DNS server. So this is normal DNS server, and this is the root DNS server. So I requested google.com. So here in the DNS server here, we have like two sections. One section is for the domain, and the other section is for the IP. So for example, here google.com, the IP for google.com is this one that we found. So actually the information are stored on the IP addresses, not the domain name. Domain name is just a name, because instead of you typing the IP address, which you will not memorize, they name them as host names. So this is the host name, this is its IP address. So it will return to you the information of the IP address, and by that you will browse google.com. Proof of that, if, for example, instead of browsing google.com, you can simply browsing using the IP address, and you will go to google.com. Notice that this is the IP address of google.com. Clicking enter, we went to google.com. So because it already understands us, the domain name system. And here we have something called cache. Inside, you can say inside the client, inside our computer. So what cache is that? Let's say it is the first time we browse google.com. So it went to the local DNS, which is the ISP, for example, the ISP DNS, the DNS for the service provider or for the country, for example. And it saved it here. So it saved it, it saved it in the cache. So whenever you wanna request google.com, second time you will request it from here, not from the DNS, because it is already saved in cache. In XSS vulnerabilities, due to JavaScript in browser, you can steal the cache details. For example, the history, the websites that you browsed, and so on. Let's say we browsed a new domain. Let's say my company domain sybitsec.com, but it wasn't found here. So if it wasn't found here, simply the DNS goes to the root DNS. Root DNS is the main DNS that has all the records inside. Also, it has IP address and domain. So it will surely have the records for Sybitsec. It will have its IP address. So here the IP address of Sybitsec, it returned it to the DNS. So DNS not just return it back to the client, no, it's also save it here. So another time on the same network, other client wanna request sybitsec.com, he will directly get it from here, not from here, because already saved it here. So this is just basic concepts how DNS works. Why I'm explaining this? Because through DNS you can obtain good, valuable information from about the target company or the target domain. Plus, you can do something called DNS spoofing. DNS spoofing, for example, spoofing the IP address of a malicious website, and for example, you type google.com, but you get redirected to other IP address by manipulating the IP address inside the host lists. We will see it practically after a while, Or you can do the opposite. You can simply monitor, do something called man-in-the-middle attack. Man-in-the-middle attack is monitoring the network. So anyone can request google.com or facebook.com. You can see the requests that are sent on the same network by spoofing DNS, also something called ARP poisoning on the same network. So we're gonna see it just to clear things out. There are some other DNS servers like top level DNS servers, so on. So what is IANA? So this is a company. Oops, IANA is a company that is responsible for it's responsible for assigning IP addresses. So we have 5 organizations. Each organization assign public IP address. You see, for example, when we go to for example, to cybitsec.com, as we remember, remote address, this IP address. So this IP address, it is assigned by these companies. Each company responsible for a region. For example, Aaron is responsible for North America. This one, Afrinic, is for Africa, and so on. So just generic knowledge. We will use it later. I will show you who is information. This is a revision. As we said, we have the web browser. If we want to browse something, first of all, it goes to the local cache. Sorry. If it is found, if the domain found and the IP address found on the local hash, it will return it to you. If not, it will check other DNS servers, recursive root DNS servers, top level servers. So whatever the server that has this information for you, it will return it to you. It will be stored in your cache. So next time, also you can do some experiment. If someone has slow internet, try to browse a new website that you didn't open it before. You will notice that at the first time the website will maybe load, for example, in 10 seconds. Try open the same website on a new tab. You will notice that it will load in 5 seconds. So it is faster. Why it is faster? Because it is already it is already stored on the local cache. That's why it will be faster. Try clearing logs of the browser, for example. You will notice that it gets slower. Okay, I will attach some resources as well. So this just for generic information. No need to go very deep inside. Just they will help us in the roots and seeds reconnaissance later on. Okay, this is just also a reminder. For example, we are the user, the browser. This is the website. We send a request to the DNS server. It replies us with a response. Just also a little bit explanation. So web application, or let's check the website. Website is made up of 2 types. The front end, it is also called the client side, and the back end, it is called the server side. So front end are all the visual stuff that we see in the browser, like programming languages used like HTML, CSS, JavaScript. The backend are the server-side languages that do the action on the server. For example, programming languages like PHP, Python, and other languages, Node.js, for example. So, and then they invented something called API. API, it is like facilitator. So it will communicate between the front end and the back end side. So from the front end, you send request to the API goes to the back end, handle the response, and then send back the response to the front end. Also, they invented something called middleware, as I remember. It is also something similar to API that also handles something inside the middle between the front end and the back end. API is important in hacking because sometimes you can understand the structure. API, it is similar as a website. So API dot, for example, cybersec.com. And you can know it from here. Sometimes they tell you API version 1, version 2, the question mark, and here the actions, the methods actually. So for example, add user maybe. So this request will add a user, for example. Delete user, and from here you can check that, for example, there where either vulnerabilities come. Delete user and ID equal 5. For example, this request will delete the user who has the ID number 5. So there is a vulnerability called either it is insecure direct object reference. This either vulnerability, you can play with the number here, for example, put 4. So anyone that changes the ID can delete any user according to its IP address. These also, we will talk about them in details. Is it possible to hack the APIs? Yeah, you're actually not hacking the API. You're actually manipulating the API to find a vulnerability inside the system itself. So API is just a facilitator for you. You can also manipulate it. Okay, so and also inside the server we have layers. So we have business logic layer. First, we have the application layer. Then we have something called business logic layer. And then we have data access layer. So these layers are just in structure of programming. Like application layer is the layer that directly deals with the back-end sides and the front end. This can be API. Business logic layer are also where pure backend is played here. Data access layer, where you create classes for the MySQL or any database. So you can some programming concepts came. So each one should have a class for the pure backend programming, class for the communication between backend and the front end, and the class for retrieving data and storing data inside the databases. So just here generic knowledge to know about them, because maybe we will face like such a stuff inside the programming programs that we want to target. Okay, let me just a little bit check my notes. Yes, now I think we can now do a simple practice related to DNS spoofing. Let me just explain what is DNS spoofing. So as you see here, so this is the client. He's trying just to make a normal request to the DNS. So attacker here injects fake DNS records. So instead of the user to resolve the real website, he go to the fake website by the attacker. So what does the attacker what attacker does actually is playing inside the IP addresses or the domains itself, inside the host files on the network. This attack can be remotely, can be on the same network. It is mostly called ARP poisoning on the same network, but similar concept, DNS spoofing. So it is almost the same. Let's try it just to see in reality how it will work. So we have the attacker machine, which is Kali Linux. Sorry. And we have the victim machine, which is Ubuntu. What? Okay. Close. So here we're gonna play it on the same network because easier. Okay. So there is a tool called Ethercap. Let me show you. Ethercap is a great tool for DNS spoofing, for ARP poisoning on the same network. It is great, which will redirect the traffic. It is very important tool. It is already pre-installed on Kali Linux. So I have these commands here. So what attacker will do? Let's check if these two machines are on the same network. So if config is a command in Kali Linux or in Linux in general, which check the configuration network information. So we have the internal IP address, the local IP address, which is running on 192.168.153.130. So this is the important, the last octet, because we will also talk about them in the port scanning sections. So let's check if this also on the same network. Maximize. Oh, okay. So also it is running on the same network. The IP address of the victim is last 128. This is 130. So what attacker will do is that he will tell the network, he will try to redirect all the connections inside the network to his machine. So by that he should create something called forwarding. So he should forward all the requests of the network to his machine. So there is a command here, IPv4 version 4 IP forward. So we want to forward all the IP addresses and connections. Then we want to edit on the host files. So in Ethercap, it has the DNS file called ether.dns. So this is the file. We want to assign that all connections inside this internal network, we wanted to, for example, here we can manipulate the website. So let's say that we wanna let the user browse a fake website. So instead of browsing the real website, attacker will allow the client to browse a fake website. So simply by changing the IP address of the real website. So let's suppose that Sided Vision, I don't know if it will work. It will work because this attack doesn't work on a lot of websites. Let's suppose that yoti.com is the attacker website. So we just want to take the IP address. There is here host. This is the IP address. It is similar technique where we did in inspect elements. So simply we go to the attacker machine here in the notepad. We type that if the victim browsed, for example, snapchat.com, we want to redirect all the IP address version 4, A stands for, we want to redirect it to this website. So snapchat.com will be redirected to yoti.com. But suppose instead of yoti, it is the malicious website of user. So for example, the attacker can create a malicious website similar to Snapchat and has sign up page or login page and steal a victim's information. So we saved it. Let's exit. And now we type a command for ethercap to start DNS poisoning. So this command will do the DNS poisoning on the network. So let's start. Okay, activating DNS spoof plugins. If we clicked on H to see the help, and we check the hosts list, the affected hosts list, we see that 128.254. Let's check this is 128. So the victim machine is affected. It is affected. So let's try here to browse some websites. Or sorry, we wanna browse snapchat.com. So see, when we're browsing snapchat.com, it got redirected to yoti.com. And as you remembered, I told you, imagine if yoti.com, suppose it is the attacker website. So not yoti. Suppose this is the attacker website and similar to snapchat.com. So do it again, snapchat.com. It went to yoti.com. So here, attacker create a website which is very similar to snapchat.com and add a login page, for example, and all the requests will be spoofed. See that we got a record that someone tried to access snapchat.com, spoofed. So it is spoofed it to this IP address. Also, you can do also something opposite, for example. Let's say you are in coffee shop or something like this. You can, instead of spoofing a real website, you can say, for example, you can say not just snapchat.com. So any website. So what does this means? Let me put it clearer here. So what does this means when we added in the host section in ethercap? star.star.star, which means any subdomain dot any domain dot com or dot net or dot anything that the user browse, it will be redirected to the attacker website. So for example, here you can do it in coffee shop. Oops. Coffee shop websites for sorry, coffee shop stores, for example, or any shop. Okay, you can do it in any shop. So on shop that has public or private shared internet, what you can do simply is DNS poisoning and ARP as well, ARP poisoning. And what you can do is simply redirect all traffic to your to your system, to your network. And what you can do is that simply you can create a fake page that, for example, says maintenance, for example. So you pop up a maintenance page inside the coffee shop or any store. You tell them for maintenance purposes, you have to re-enter your password or log in using Facebook, log in using Google, and by that you will gather all the traffic inside all the network traffic inside this shop. So for example, let's try it here by doing star. So any website browsed. So let's save it, and let's activate the capturing. You can download. Our friend is asking if the fake page would it be ready-made or we have to create it. There are some services that create it for you. I think in Kali Linux there are social engineering framework that will create the page for you for IRP poisoning purposes and DNS poisoning. Uh, and you can create it if you are a developer. You can create it in pretty way. So let's target the victim, suppose victim in the shop, and we're intercepting the traffic. So if we want to try to browse google.com, so google.com, it redirected us to yoti.com. Let's try youtube.com. Okay. youtube.com. It is not working this. Okay, so let's try, for example, GitHub. It is redirected to yoti.com as well, but a new page, which is hotspot login. Let's try facebook.com. So notice some websites will not directly redirect it. It is okay because they are monitoring for the certificate. That's why it is important to use secure certificate. Let me check cybersec.com. Yeah, also some of them. So this is example. Any website will be redirected to yoti.com. Let's check google.com here. So in case of this problem, yeah. Wow, they are forcing to be and to enter the legitimate website. So in case of this problem, simply you can try it again. So let's check the logs. Here the logs, we're detecting that the target IP address that we're targeting, for example, all the connections, we didn't just monitor the websites that we entered. For example, see that there is a record for go.hackerone.com. Let's check the victim. And if we check here in the history, we have go.hackerone.com. So it also monitored everything related to our history, all the browsed websites. So see how it is dangerous. Not just the website that you newly enter, but also the websites that you entered before. So it redirected for us a lot of other websites, api.hackerone.com, go.hackerone.com, and other websites. So this is DNS spoofing and such stuff. This is, I like to do practical examples to show you how such stuff are dangerous. So always be aware when connecting to a public internet. Try to use VPN services, especially in, for example, here in Dubai. We have free internet all over the places. Wherever you go in a mall or shopping center or anything, there is a free internet. So keep your VPN running. Okay. I'm reading the comments, so in case I missed anything. So what we forward exactly, we forward all the traffic on this network to our system. If we wanna check for ARP poisoning, for example, to understand more, ARP poisoning, okay. Yeah, this one is good. So here we tell the hacker will tell the network will tell the network that I am the victim device, and he will tell the victim that I am the network device. So the victim, instead of forwarding the request directly, the packets directly to the network, and the network forwarding the packets directly to the victim, they will forward it to the attacker, and the attacker will forward it to the victim. And otherwise, the victim will forward the traffic to the hacker, and hacker will forward the network. Everything is running smoothly and easily, but the hacker is seeing all the stuff like this one. So attacker gives his IP address to the router, for example, and the client. He tells him, "Hey, I am the client," and he tell the client, "Hey, I am the router," and all the traffic is going through the attacker. This is also a ARP spoofing attack. Okay. Okay, so how this is useful for us in bug bounty? Honestly, in bug bounty, DNS spoofing, DNS poisoning, ARP, such stuff, they are not useful, but it is important to understand them because in bypassing firewalls, sometimes you will face this. So let's say I have real examples, but they are IP addresses from work. I can't share them. Let me just think fast. Okay, I will explain it here, and in case we did real attack scenario, we will show it practically. So some programs hide their real IP addresses. Okay, so they hide their real IP addresses. They replace it with firewalls, firewall IP addresses, like a Cloudflare, web application firewall, like Cloudflare. Why? Because by that you cannot execute any malicious stuff, nor XSS, nor SQL injection, anything harmful, you will get banned or blocked. But at the same time, so you can at the same time browse the target with the firewall WAF IP and the real IP. So the problem is that you have the WAF IP address. You're browsing the target website using the WAF IP address, but you're not browsing it from the real IP address. That's why we do reconnaissance. And sometimes we find the real IP address. So sometimes we find the real IP address. So suppose that the application, for example, website, it is called, for example, target.com. The WAF IP address, for example, 120.1.1.1, for example. We found the real IP address, and it was 134.1.1.1. So in this case, what we will do, we modify our hosts list in our computer, in our system. we modify it and we add the real IP address. It is like DNS spoofing. We spoof the real IP address. How this happened, I will show you. Just I need to remember where the etc file is stored. etc host. So etc hosts is stored in this path. So inside any system, in Kali Linux, in Windows, in any system, there is this etc-hosts. It is like the ethercap one, if you remember, that we modified it. So we have to go to here on our Windows. So let's open it as Notepad. So this is the etc hosts. And simply we add the real IP address, which is this one. We added it, and we add the target. Sorry, we save and we close. And now when we want to browse the target website, so usually when we want to browse target.com, it will redirect us to the WAF IP address. So now after we saved it in host, the real IP address, when we browse on the Google Chrome target.com, it will redirect us to the real IP address. Okay, so how did you find the real IP address? I told you. We analyzed the application, mobile application. We analyzed the source code on GitHub. We analyzed the request responses of the target system and all the subdomains. We did all the reconnaissance. That's why we discovered some IP addresses. Then we tried to match them with all the hosts that were blocked by a firewall. Yeah, here it depends. So it depends what you are targeting as well. So in case you're targeting an application that that didn't do any security protections on its real IP address, once you bypassed it, it is easily to do a lot of stuff. Okay, so just to see if I talked about all the things that I wanted to. Yes. So now we're gonna start with the methodology. Oh, sorry, I forgot to talk about one topic as well. So we forgot to talk about the HTTP. So HTTP is the same. So we talked about that we send a request, like here, for example, we send a request to google.com network reload. So you can see there is something called request method get. So we're gonna talk more about them. What are the request methods? This is also very important. So we have some resources here. So we have couple types of request methods. Let's try opening Burp Suite and talking a little bit about, for example, yoti.com. This is also important, and I will discuss some vulnerabilities through it. So, let me just slightly enlarge the fonts for you. I think they are now better. Yes. So see that we can remove all cookies for now, or at least keep one cookie, so we can avoid. Okay. So request methods. You know that there are more than one type of request methods. Request methods like this you see here. Sending a request, we have get. Yes, we can use Postman as well. But the Burp Suite is good because Postman mostly for API calls, sending requests and monitoring stuff. Here is better. So get request, post request, such on. So get request is simply used to retrieve information from the server. So we're gonna need to view the structure of the website of yoti.com. So we sent a get request and we got this response. So we got this response. This is this response. Also in bug bounty, we do something, for example, right-click, request, right-click, show response in browser. So we click on it, copy the response, paste it here in the browser, and we got the same response, which is the same as here. So this is the front-end language translated into or interpreted into the web browser. So we have the head. So what is head? Head is the same as get, but just it prints the responses of the headers. So inside every request, there is headers and body data. Headers data and body. This is get request, so there is no body data. Here, this is the header, this is the body. So let's try changing get to head. See that we got just the header information, not the body information. While if we return it to get, we got also the body information. So why this is important? Sometimes you're trying to brute force something, you brute force directory here. So sometimes you need to brute force, for example, this place, and monitor for the status code, what it will be, 200, 302, 301. We can try it as well. Let's try it. It will be faster. So intruder is a place to brute force. Payloads. Let's enter the dictionary payload. Let's start brute forcing. So see, we're getting 404 response. 404 means not found. So 404 not found. But let's say we're gonna use, so if we used head, just 404 not found and the request headers. But if we used get, we will get also the HTML response. Why brute forcing subdomains? So for example, brute forcing directories files is much better in head, because in head it will be it will be faster. Plus, it will check if the content is found without the need of loading it. So it will reduce the traffic for you. That's why sometimes in brute force we use head. So it is less detected. Okay, this is also important information. A few of usually tech guys know it. Post request is used to send any data in the body, like login panels, for example, login forms. We can check. We have login here. We need to log in with the username or password. Okay, let's try any login page. So already mentioned, we also we will talk about Google Docs. Also, you can use in URL login. So this is easier for you to find login pages. We found another login page for Yoti, which is this one, identity.yoti.com. So let's try login. Let's enter any email, test@gmail.com and test@123. Let's try logging in. Invalid email or password. So let's check the requests in Burp Suite. Proxy history, search for the login, identity post auth, repeater. So see that here we send the request using post method, and the data we send them in the body, not in the header. So we can, for example, do instead of post, we can do get. But this data now will be sent inside the request parameters here. So we add question mark email equal test@gmail.com and mark password equal test@123. And we can send the request. Sure, we have to remove this one. And we can check for it. So what is said 405 method is not allowed. So this is a response status code. And the reason for it. Why method is not allowed? Because this login endpoint, which is IAM/API/auth, only accept post request. It doesn't accept get request. That's why here, if we send it, it will show us invalid email or password. So this is the post request. Put is almost the same as post, but it is more for uploading content. So if you wanted to upload a file, if you wanted to upload data, you use put instead of post. So post can be used for communication, sending information, checking authorization and authentications, but put for uploading stuff to the server. Let's try here put. We change it to put. We will see if there is allowed method. See also it is not allowed, the put request here. So some vulnerabilities arise from put request. Let me check for RCE via put method, HackerOne, reports. I remember once a hacker found an RCE using put request. Yeah. So what sometimes programs miss and websites miss is that they forgot to disable put method. So what you do is simply you remove this stuff, you enable put, and here you download a file. For example, PHP, you download a PHP file. I forgot how it is the structure. Maybe we can check from this guy. It is not allowed. But I found before a report. Yeah, like this. So what you do is that you upload a file on the website just because they accept put method. So like this, you use put, you add any file, for example, test.txt, you add here post data, send request. If the method is allowed, the file is uploaded. So in case of this, you can easily upload reverse shell. You can upload a PHP file and obtain reverse shell, obtain RCE. So some website missed it. Now I think in programming they are automatically disable this stuff. I found before, yeah, this one I think. No, some guy maybe 5 years ago found one and they awarded him good amount of bounty just using simple put request. Okay. So we also have delete for everything to delete stuff. So here delete, for example, delete an article ID / for example articles and ID equal 5. For example, it will delete the article with ID 5. And this is important for IDOR. You can try IDOR, for example, try adding random numbers. Maybe they will be deleted. So also here method not allowed. So this website, they protected the methods. There is connect just to establish connections. Connect, I think it has some vulnerabilities. No. So this is important, the options. So connect is just to check if there is a connection. Let me try it. So let's try connect. If there is connection to this target, if it's replying, it's like pinging the target. Also, it's not allowed. Let's just search for another website that has this method allowed. Maybe my website will be affected because, I didn't do security for it. Let me check CyberSec. Let's try connect. Yeah, you see below, stream received fatal error. So it is not. Let's try options. Yeah, this is important. So what is options? So connect is just to check if the website resolves or not. It is simple. Options is important. Why options is important? It shows you the allowed methods. So this website allows the methods options, head, get, and post. If we get back to Yoti, if you remember, let's check options. This domain just allows, also method is not allowed, so they are protected well. So my website tell you in the response that the allowed methods are options, head, get, and post. So this is important. For example, for any website you target, check directly for options. If you see put, try to upload a file, and maybe you will get RCE if they didn't have some enforcements. Yeah, and a trace. So I think this will not work because it is not allowed. Yeah, it's not allowed. Oh, it worked. It worked. So what the trace does is simply it sends the request header here. It sends them in the response. Same as the response. But now it is worked, but it is not active. So how trace is dangerous when there is XSS in cookies, for example, or in any header. So what a trace does is that it takes all the headers here and posts them back in the response. So let's say the website is vulnerable to XSS and you planted XSS here. For example, so whenever you send a request, the cookies will be played here, and here you will get the XSS. That's why trace is sometimes dangerous. Why you do trace instead of get if you found XSS? Because if you have HTTP only flag on cookies, you can't steal cookies. We will talk about them later. HTTP only flags. because every cookie can have a security flag, secure flag, sorry, and HTTP only flag. So HTTP only flag, if it is enabled in a cookie, you can't steal it using XSS. That's why we use trace, because it will interpret the cookie itself in the response. Yeah, and sometimes, yeah, sure, ask.
Yeah, Ahmed. So here is like when we look for the options method to look for the available HTTP methods. So we should always look for anything like on the index, I mean the root directory, or anywhere if we find any like directory any directories if we found, we can look also on that particular directory what are the HTTP methods are enabled, or how we have to look for it basically.
Yeah, absolutely, absolutely. Because sometimes they enable on a different, for example, directory. For example, for just maybe users directory, enable put, because you will upload a profile picture, but disable it on other directories. So yes, you are right. So sometimes we can look for each directory. We can look for options. So
Again,
we will play it. We will play with it when we reach bug bounty hunting stuff. So we will do some hacking, and we will try manipulating these request headers and request body, so to check, to expose information. And also why we change, we play with uh, request methods also, because sometimes you will expose some errors. Sometimes stack errors will happen. Simple bugs will happen. For example, they will disclose an IP address, which may be a real IP address for a file, for a main application. Sometimes they will expose the version number of the programming language. It may be vulnerable to SCVE or to such kind of vulnerability, server name, and so on. So yes, it's important to try on also directories. Uh, Now we just want to talk about status codes.
I just have another question before leaving the request
Yeah,
method.
yeah, sure,
Uh,
ask.
About the delete method, is it just I can delete things like ID equal a number, or can I delete a whole directory? What can be deleted? In,
No, you can't delete directory. You delete the uh, the files or the data. So it deletes, you delete the stuff that can be deleted. For example, the application program to be able to delete document files. So you can just delete document files because it is programmed to delete document files. But the delete request also, it is also will be implemented inside the application. So you will just use it to find some IDORs, to find some uh, issues that can be bypassed by authorization problems.
Can I ask another question for this?
Yeah, sure.
Yeah, for and correct me if I'm wrong in this, but I do believe that all methods are already has a specific implementation. For example, put if they didn't have the implementation for the put method to insert or create a new record, whatever the record type is, there is nothing would matter with using put, even it is allowed on the server side from the Nginx configuration, for example. We are
Yeah,
not
yeah,
we're not be
yeah,
able.
but
Am I right in this?
yeah, absolutely, absolutely. But also you can have a chance. For example, maybe they disable it on the server. Sometimes they for example transfer the domain to a new server. Uh, they, for example, forgot to do some manual stuff or some settings. So you have to put these chances in front of you,
Okay.
because sometimes it happens. Sometimes it happens, and you find vulnerability using put request.
Okay. Sure. Cool.
Yeah,
Thank you.
but yes, in general, by default it will be disabled. But when we talked in the first session about the usability stuff, sometimes for the easy usability for users, they have to enable it, for example, but they forgot to secure it. So you can take this chance.
Yeah, but I think you misunderstanding me in this. I mean that we need to have a predefined implementation in the server side for doing put request, post request, or whatever request we are
Yeah,
dealing with.
absolutely,
Uh,
absolutely. It will be used.
yeah.
So put request will be used on in the web application, for example, in a certain operation, but you change it for another operation. They forgot, for example, to implement some restrictions, and you can able to exploit it.
Okay. Thank you. Cool.
Yeah, I will also attach these CRL materials on the group, so don't worry. We just want to talk about last thing here, which is the HTTP responses. Uh, Here, the status code. It is also important to know the status code because sometimes you face such situations in bug bounty. So the important status codes are the 200, 300, 400, and 500. If you can see here, we have 404. 400, especially 404 means not found. So the directory that we are searching for, which is /users, is not found here. 200, anything related to 100 means a success. So remember here, like 405. 405 means method not allowed. Remember here in the normal response, it was 200. So the response was successful. Everything related to 400 is any error. Invalid login, not found directory. So let's change it to post. Here we got 400, bad request, because there is wrong credentials. And there is 500. 500 is for any server issues, like internal server error, which is 500. Also 503, service unavailable or service unreachable. So the most important responses are 200, 301, which is, and 302, which are responsible for a redirect. Sometimes in a successful brute force login, you will get 302. You will know that it is successful login. 404 for any content not found. 4010 for anything gone. Anything gone, it means that there was a content here, but it's now no longer available. Service unavailable means that also this page is found, but some issues on the server made it to be temporary not available for maintenance or overloading, for example, like denial of service attacks. Yes, I will share the recording. So all recordings will be shared. Okay. So I think for now, this is enough content for now. Next week, we will start in the reconnaissance practical stuff. So just a brief details. So next week we will start in the reconnaissance methods. We'll talk about some slides just quickly, and then we will go in hands-on for who is DNS information and other stuff. This for who is and DNS, we will use the explanations and the information that we use now in the DNS stuff, client server, how it works, and the IP addresses, so on. So all of this will be used in the bug bounty hunting concept. If you have any question, you can ask now because we finished.
I just have a question, Ahmed.
Yeah.
Whenever I'm testing on a website that is behind the firewall, Should I hide my real IP if I sent too many malicious requests or something? It might block me.
Yeah, usually the firewalls work. Usually firewalls work in two ways. Some block you for any harmful payload. Could be, for example, a question mark, or could be like this. It will detect it as XSS, for example. It will sometimes will be select star. It will detect it as SQL injection or wait command for SQL injection. So any malicious stuff you do like this will be block you. But the block per malicious command. So it will block you just when you enter this stuff. So if you entered normal content, after that you will not be blocked. And the other kind of firewalls is that they block you for several or certain number of requests. So if you tried, for example, to request to make a request to an endpoint, for example, more than 10 times, you will get blocked for some couple of hours or for a day. So you have to identify which firewall you're dealing with. If it is like this, so no need to change your IP. If you're trying to send a lot of requests and you got blocked, you have to change your IP address. And as an advice from me, any firewall that works on blocking you from large number of requests, don't send a lot of requests. Just send request, wait 2 seconds or 1 second, send another request, so you can avoid being blocked. Any other questions? Okay, I think we're done. Okay, until next time, we'll see you. I will send all the resources now after a while, and I will send the recorded session. I will check if there is small task that you can do. If you have time, it's okay. So, and I will attach the slides that we talked about yesterday. Okay, have a great night and stay well. See you.